what are the coordinates of the orthocenter of triangle ABC? So this is something that we are going to encounter mostly a circumcenter or orthocenter problem, and the easiest problems to deal with are right triangles, and this one just so happens to not be a right triangle, so we are going to sort of need to do a little extra work to find the altitude of this triangle. Okay, so what we're going to do is we are going to use the slope of CB to find the altitude that comes out of A. Okay, so before we do any of that though, let's just be happy that we have one altitude already popping. So from C, we're lucky that one of our, well, let's use the tools we have available. We're lucky that one of our altitudes is actually one of the axes. It's on the grid line because AB is a horizontal line. So a horizontal line has a slope of zero, so it does not rise or fall, and a vertical line has a slope but that's undefined. So you have that, and they're opposites of each other because you can't, if you have a slope of 0, you can't take the reciprocal of 0, so that's undefined. So we already have one of our altitudes, so we know that our point of concurrency of the altitudes must land on this yellow segment because that is one of the altitudes. And we know that the point of concurrency of the other, there's two altitudes, and there's where they cross this altitude is going to be the point of concurrency. So we really only have to find one other one, because wherever two altitudes meet, then the third one's going to meet there as well. So we have a couple things to consider here, right? And this becomes a problem that you already know how to solve. So think about the question that's like this. What is the equation of a line that passes through vertex A? Sorry, I had just a little technical difficulties there. Actually, instead of putting point A, we're going to actually put the coordinate, because that's what you would see. If this was an algebra problem in an algebra class, it would say, what is the equation of a line that passes through -2, 1, and is perpendicular to CB? Okay, what's the equation of a line that passes through -2, 1 and is perpendicular to CB? Because that's exactly what the altitude is. Okay, the altitude goes from the vertex to the other side, and it is perpendicular to the other side. So an altitude comes from the vertex, which is point A in this case. So that's -2, 1. And is perpendicular to the opposite side. That's exactly what this is saying, just in a different way. The equation of a line that passes through the vertex A, so it starts from the vertex, and is going to be perpendicular to the opposite side, which is CB. So in order to find the value of the slope for a perpendicular line to CB, we need to find the slope of CB. So we're going to find CB slope. We're going to identify the perpendicular slope, and then we're going to find B, and then we're going to draw our line. And then we're going to identify the point of concurrency. Okay. That looks like more than it really is. All right. So if C is 0, 4 and B is 2, 1, then we're going to do change in Y over change in X. So we have 4 minus 1 over 0 minus 2. We get 3 over negative 2. The perpendicular slope would be 2 over 3. Heyo. Done. Done. Okay, let's find B. And we are going to use the information that we have about A, which is negative 2, 1. And we're going to find B, because we know that the equation has to be y equals mx plus b. So we want to know, where does this line cross this y-axis? Because then that's going to be the point of concurrency as well. We can just stop there, but I'll show you. I'll draw the line just so you see that it is perpendicular to that other side. So y is going to be what we're given in the problem, which is 1. M we found to be 2/3 because it has to be perpendicular to 3 over negative 2. X is negative 2, and then we don't know B. 1 equals negative 4/3 plus B. This is really 3/3. So 7/3 equals B. So our point of concurrency is actually going to be 0 7/3, which is what? 2 1/3. So I'm going to take a look. This is 3 right here. So we'll do something like this. Here. Okay. So we have this situation now where we could say, all right, well, I know this line is perpendicular to CB, and it goes through A, and it also goes through this point on the y-axis, which is the y-intercept, and that y-intercept is 7, 3. So your final answer is the orthocenter is going to be at 0 7/3. Or you could say 0 and 2 1/3 if you want. That's fine too. And then if you wanted to, you could do the math to find the other orthocenter, or the other altitude. But in reality, you just have to make sure that 2 of the lines cross at that one point, and then you could take for granted that the other one crosses there as well. There you go. Orthocenter. Do not mistake this. These are not bisectors. They just are perpendicular. They're not bisecting the side. Fun fact.